Good morning students. In previous class we have learned redox reactions. Redox reactions in terms of electron transfer. That means loss of electron is called oxidation and gain of electron is called reduction. And the competitive electron transfer reaction also we have seen in previous class. So now we will discuss about a new concept that is very important, oxidation state and oxidation number. So both are same, oxidation state, it is also called oxidation number. So how to determine oxidation state or oxidation number of an element? So in previous, redox reactions in terms of electron transfer can explain only ionic compounds. But most of the reactions are carried out in covalent bonds. So how can determine which element undergo oxidation or which element undergo reductions in covalent compounds? That is a very important task. We can determine which element is oxidation or which element undergo reduction. So by the using of concept that is oxidation state or oxidation number of an element, we can determine easily which element undergo oxidation or which element undergo reductions in covalent compounds. That's why this concept, that is in oxidation state or oxidation number concept, should learn, because we can easily identify which element undergo oxidation or which element undergo reduction in covalent compounds. First of all, we will see the oxidation state or oxidation number definition. It is a general definition, that is the number of electrical charges it carries is called oxidation state of an element. So first of all, we will see some examples. Best example, that is 2 moles of hydrogen gas is reacted with 1 mole of oxygen gas to form 2 moles of water. So this is one of the reaction. Here water is a covalent, polar covalent bond or polar covalent compound. Okay, so from this, in these reactions we can identify which element undergo reductions or which element undergo oxidation by the using of oxidation state or oxidation number. In free state, every element should possess zero oxidation state. So oxygen is also zero oxidation state. But whenever in the presence of compound or that free state is converted into compound, so what happened here, the hydrogen can exhibit the +1 oxidation state and the oxygen can exhibit the -2 oxidation state. Now here hydrogen oxidation state is 0 to +1 oxidation state is convert. Now oxygen oxidation state is also convert 0 to -2. Okay, so here you will see one trick is there, that is for example it is a 0 oxidation state, +1 oxidation state and +2 oxidation state. So here left side -1 oxidation state and the -2 oxidation state. If an element loss of electron, so it is undergo +1 oxidation state. 1 electron loss, 0 to +1 oxidation state. If another electron will be lost, that +1 to +2. If -1, if the element oxidation state is a -1, -1 to 0 means loss of electron. If 1 electron will be lost, it is a converted 0 oxidation state. If -2 to -1, that means loss of 1 electron. Okay, so now -2, if the element oxidation state is -2, if the loss of electron, it is converted into -1. If another electron will be lost, it is converted into 0. If the another electron will be lost, it is converted into +1. If the another electron will be lost, it is converted into +2. So here from left to right we will see the all electrons will be lost. That's why here loss of electron is called oxidation. Okay. For example, another one is if the element containing the +2 oxidation state, that +2 oxidation state will be converted into +1 oxidation state whenever if accepting of one electron. Okay, if accepting of another electron, that +1 oxidation state is converted into 0. If accepting of another electron, that 0 is converted into -1. Okay, if another electron will be gaining, -1 is converted into -2. So in right to left what happened, electrons will be gaining. That's why gaining of electron is nothing but reduction. Okay, and here from left to right -1 to +2 means is the oxidation state will be increases. So loss of electron is called oxidation, or if oxidation state increasing of an element, it is also called oxidation. Next, if oxidation state decreases, from right to left it is a decreases. If oxidation state is decreasing, that element undergo reductions, or gaining of electron is also called reductions. So it is a one of the trick you will easily identify. Now you will see here the hydrogen oxidation state 0 to +1. So now 0 to +1, the oxidation state is converted into 0 to +1, means 0 to +1 means accepting of one electron. That's why accepting of electron, that means loss of electron. So 0 to 1 means one electron will be lost. Loss of electron is called oxidation, or 0 to +1 is nothing but oxidation state increases. That's why here hydrogen undergo, which one is hydrogen is oxidized. So here one hydrogen atom undergo +1 is a 1 electron, but here how many? So loss of electron is nothing but oxidation. Loss of electron, because oxidation state is also increases. So oxidation, according to oxidation state, hydrogen undergo oxidized and the oxygen undergo reduced. So oxygen is undergo, O2 is undergo reduced, and the hydrogen is undergo oxidized. So oxygen means reduced means gain of electron. So gain of electron is nothing but reduction. Okay, so in terms of oxidation number, we can identify which element undergo oxidized or which element undergo reduced. In covalent compounds, that is the essentiality, or that is the importance of oxidation number. In covalent compound also we will identify it. So here I hope understand. Okay, if you see here is also, this is a box, you will remember that. Hydrogen oxide, once again repeated, hydrogen actually in free state it is a 0 oxidation state, but after the reaction it is converted into +1. So 0 to +1 means loss of electron. We know that loss of electron is nothing but oxidation, or another type is also we can identify it. If oxidation state 0 to +1 means oxidation state is increases, oxidation state will be increases. So 0 to +1 oxidation state increases, that is also oxidation process. Now here gaining of electrons means here 0 to minus 2. So here 0 to minus 2 is given. 0 to minus 2. So 0 to minus 2 means is a left. That means right to left side. 0 to minus means one electron gaining as well as the another electron gaining. So 2 electrons are gaining and 0 is converted into minus 2. That means oxidation state decrease or gaining of 2 electrons. Okay, so that's why oxygen undergo reduced, that means gaining of electron, and hydrogen undergo oxidized. So we will see another example for more understanding. That is 1 mole of hydrogen is a gas. 1 mole of hydrogen gas is reacted with 1 mole of chlorine gas to form 2 moles of hydrochloric acid. So you will see here every element in free state, that means molecular state, the oxidation state is 0, and here is also 0. Now hydrogen is converted into HCl, means that hydrogen state, oxidation state is +1 and here -1. So hydrogen oxidation state 0 to +1. We know that 0 to +1 means loss of 1 electron. Okay, so loss of electron, we know that loss of electron is called oxidation or oxidation state. According to oxidation state, here 0 to +1 means increasing. So oxidation state is increasing, it is also called oxidation process. Next, another one, 0 to -1. So chlorine is undergo 0 to -1. 0 to -1 means gaining of electron. That's why here we will see that gaining of electron is reduction, or oxidation state 0 to -1 means decreasing. Oxidation state is also decreasing. This is called reduction. So from this we can conclude that hydrogen undergo oxidize, and chlorine undergo reduce. So simultaneously oxidation as well as reduction both will be exist. That's why this reaction is called redox reaction. Next, another example. If methane gas is reacted with 4 moles of chlorine to form carbon tetrachloride liquid plus 4 moles of HCl gas. Now you will identify the oxidation state. Carbon oxidation state is always -4 because the oxidation state of the hydrogen is +1. Now Cl2 in the free state, that's why it's a 0 oxidation state. Now here is also +4 oxidation state carbon, and the chlorine is -1 oxidation state. Next, hydrogen is always +1 oxidation state and the chlorine is always -1 oxidation state. Now you will see here carbon undergo -1 oxidation state to +4 oxidation state. For example, here you will see -4 to +4. So here -4 to +4, -4 to +4. That means oxidation state is increases. So carbon oxidation state undergo -4 to +4. minus 4 to plus 4 means here minus 4 to plus 4 means left to right, means oxidation reaction, because losing of electrons. So loss of electron is a oxidation, or oxidation state increases. Minus 4 to plus 4 means oxidation state increases. So that's why carbon is oxidized. Now chlorine, 0 to -1. So here is also. So 0 to -1. 0 to -1 means here you will see 0 to -1 means oxidation state decrease as well as the gaining of electrons. Oxidation state decrease, gaining of electrons. So that's why here we will write the gaining of electron is nothing but reduction, or oxidation state will be decreases. If -4 to plus 4 means here -4 is there, -3 -4. So here +3 +4. -4 to +4 means losing of electrons. I hope you understand. So carbon undergo oxidized as well as chlorine is reduced. So like this manner we will identify in polar covalent compounds which element undergo oxidation and which element undergo reductions by the using of oxidation state. And from this we can easily explain that oxidation state increase is called oxidation. If the oxidation state is decrease is called reduction. Next, but whenever we identify oxidation state or oxidation number of an element, some rules are formulated. Okay, so we will see the rules. Some rules are assigned to oxidation number for an element. So first rule is the oxidation number of each atom in free state is 0. Okay, for example, H2 molecule, the oxidation state is 0. Chlorine molecule, the oxidation state is 0, because these molecules exist in free state. That's why this oxidation state is 0 always. Next, oxygen molecule oxidation state is 0. Next, ozone molecule oxidation state is 0. Next, P4 molecule is also oxidation state is 0. Sulfur 8 oxidation state is 0. Some metals, sodium in free state is 0 oxidation state. Magnesium in free state, the magnesium oxidation state is also 0, and the aluminum, so on. The oxidation number of each atom in free state, the oxidation state is always 0. This is the first rule. Next one is second rule. For ions, oxidation number is exactly equal to charge on that ion. Charge on the ion. For example, Na plus, if you take an Na plus, sodium plus ions is nothing but how much the oxidation state is always +1. Magnesium always exhibit the +2 oxidation state. Charge is +2, that's why here oxidation state is +2. Aluminum always +3. So oxidation number is exactly equal to charge on the ion. Cl minus, oxidation state is -1. O2 minus oxide ions the oxidation state is -2 for ions. The third rule is, generally oxygen common oxidation state is -2 in oxide form, but it can exhibit the -1 oxidation state. It also can exhibit the -1/2 and +2 and +1. So now we will see. If we take any calcium oxide is an example, calcium oxide. So in this oxidation state of the oxygen is always -2. So oxide, in the form of oxide, oxygen oxidation state is -2. But whenever in the presence of peroxide, H2O2 is nothing but peroxide. In the peroxide, it exhibits the -1 oxidation state. The compound molecular formula is a H2O2 or Na2O2. So these compounds, in these compounds, the oxygen oxidation state is always -1. Here +1 of hydrogen. So in the peroxides, oxygen oxidation state is -1. And the best example for the KO2 superoxide, that is a -1/2. Compounds are potassium oxide KO2 and rubidium oxide RbO2. So in this presence, the oxygen in these compounds, the oxygen oxidation state is -1/2. It is also called superoxide. Sometimes here difluorooxygen, the oxidation state of the oxygen is +2. Difluorooxygen. So, or oxygen difluoride. How much the oxidation state is? A +2 oxidation state. Next one is O2F2. Dioxygen difluoride. So in this oxidation state is +1. So oxygen can exhibit the different types of oxidation state. In dioxygen difluoride, it exhibits the +1 oxidation state. Oxygen difluoride, it exhibits the +2 oxidation state. Whenever in the presence of potassium, it can or rubidium, it can exhibit the -1/2 is nothing but superoxide. So number of times asked in the exam, superoxide oxidation state, that is the oxygen oxidation state. Whenever in the presence of hydrogen peroxide, the oxidation state of the oxygen is -1, but common oxidation state of the oxygen is -2. It is a general oxidation state. అంటే మనం ఎక్కువగా చూస్తాం, కామన్ గా చూసే ఆక్సిడేషన్ స్టేట్ మాత్రం -2. సో దీస్ ఆర్ రేర్ ఆక్సిడేషన్ స్టేట్స్. Only few compounds containing these oxidation states of the oxygen. Next, fourth one, hydrogen. Hydrogen common oxidation state is +1 always, but sometimes it is also exhibit the -1 oxidation state is also, here -1. Whenever hydrogen is combined with electropositive element like this sodium and the lithium and potassium like this. So these are first A group elements we called as a electropositive elements. Whenever hydrogen is combined with electropositive elements, the oxidation state of the hydrogen is always -1. Okay. If hydrogen combines with electronegative element, for example H2O, next one is H2SO4. Okay. If the hydrogen is combined with electronegative element, in this hydrogen oxidation state is always +1. If the hydrogen is combined with electropositive element, that is a sodium, lithium, potassium, the oxidation state of the hydrogen is -1. You easily remember that. Whenever it is combined with electronegative element, it is a +1. Whenever hydrogen is combined with electropositive, it exhibits the -1. So this is the fourth rule. Next one is fifth rule. So halogens common oxidation state. So generally halogens are exhibited in the X. That means fluorine, chlorine, bromine, iodine. So these are the halogens. We call it as a halogens. General halogen oxidation state is always -1. But sometimes some halogens can exhibit the +1, +3, +5, +7 oxidation state is also. So generally oxo acids can exhibit the +1, +3, +5, +7. Oxo means one oxygen group is present as well as the one hydrogen group is also, one oxygen atom is present as well as one hydrogen atom is present. We called as those compounds are called oxo acids. Best example for the oxo acid is a perchloric acid, that is a HClO4. In this chlorine exhibit +7 oxidation state. Next HClO3. In this chlorine oxidation state is a +5. HClO2. In this chlorine oxidation state is +3. So in higher level you will study. Just you will see here halogen is also can exhibit the different oxidation states. So depending upon the compounds or depending upon the other element can combined with halogens. Okay. So generally oxo acids can exhibit the positive oxidation state. Oxo acids can exhibit the positive oxidation states. But common oxidation state of the halogen is always -1. General it is a common oxidation state. Fluorine, chlorine, bromine, iodine. So like this Cl-, F-, Br-, I-. General common oxidation state. So these are assigned for the oxidation states rules. And another important pronunciation is a Stock notation. Alfred Stock can explain oxidation state notations. That's why we are called Stock notations. So Alfred Stock, who was a scientist, he gives some notation for explain the oxidation state. For example, RS chloride. It can oxidation state of the Rm is a denoted by Roman numbers, that is a 1. Here 1 oxidation state RS chloride. So this is called Stock notations. Next one is auric chloride. Auric chloride means here 1, 2, 3. Rm can exhibit the +3 oxidation state. Auric chloride. Next, stannous chloride. Already we know that stannous chloride in redox reactions. Stannous chloride, Cl2. And next one is stannic chloride, plus 4 oxidation state, stannic chloride. And the best example for the mercurous chloride and mercuric chloride, that is a Hg. Hg is a plus 2 oxidation state. Whenever combined with Cl2, it is reduced to Hg to Cl2. So mercury oxidation state is plus 1 in Hg to Cl2, and mercury oxidation state is plus 2 in HgCl2. So mercury, that means HgCl2 is reduced to Hg to Cl2. So this notation of the oxidation state is called Alfred stack notations. You will see, or you should solve problem 5.12 in your textbook. Some problems are there, that is a 5.1. You will solve it. So from these notations we can conclude that oxidation state of an element is increase is called oxidation. If the oxidation state is decrease of an element is called reduction. So this notation is called redox reactions in terms of oxidation number. Redox reactions can be represented in terms of oxidation number. If the oxidation state or oxidation number increases, that element undergo oxidation. If the oxidation state decreases, that element undergo reduction. Next, very important, oxidizing agent or oxidant. A substance which increases the oxidation number of an element or itself undergo decrease in oxidation state is called oxidant or oxidizing agent. Next one is reducing agent or reductant. A substance that lowers the oxidation number of an element and itself undergo increase oxidation number. So don't confuse. I will give the explain. We taken one example. For example, two moles of, so we taken one example. So from this, which one is oxidizing agent or which one is reducing agent, we will identify it. So copper in this, before the reaction, +1 oxidation state, but after the reaction it undergoes 0. That means oxidation state will be decreases. Oxidation state will be decreased. Oxidation state will be decreased is nothing but that element undergo reduction. So reduction means gain of electrons. Okay, 0, +1, -1. So +1 to 0, +1 to 0, +1 to 0 means here left side means gaining of electrons. So gaining of electrons we called as a reduction, or oxidation state decreases. +1 నుంచి 0కి వచ్చిందంటే ఆక్సిడేషన్ స్టేట్ డిక్రీజ్ అవుతుంది. ఆక్సిడేషన్ స్టేట్ డిక్రీజ్ ఏమంటారు? రిడక్షన్ అంటారు. ఓకే, అండ్ we know that next, if sulfur, if you see the sulfur here, sulfur -2, so oxygen here -2, here -2, that's why there is no change. But if you take in sulfur, here -2, here +4. -2 means like this, here -2, +4 means here. So -2 to +4. +4 means here loss of electrons. So loss of electrons is called oxidation, or oxidation state is -2 to +4. అంటే మైనస్ నుంచి +4 అంటే ఇంక్రీజ్ అవుతుంది కదా. So oxidation state is also increases. Oxidation state increase nothing but oxidation. So sulfur undergo oxidation. Oxidation. Okay. So here copper +1 oxidation state, +1 to it undergo 0. Next sulfur element, that oxidation state is -2 to +4. So you will see oxidizing agent, a substance which increase the oxidation number. So here a substance which increase the oxidation number, a substance which increase the oxidation number of other element. For example, here copper can helps the increase the oxidation number as a sulfur. Sulfur is -2 to +4. అంటే ఇది కాపర్ సల్ఫర్ యొక్క ఆక్సిడేషన్ స్టేట్ ని ఇంక్రీజ్ చేస్తుంది. నెక్స్ట్ అండ్ ఇట్ సెల్ఫ్ అండర్గో డిక్రీజ్. అంటే కాపర్ ఇట్ సెల్ఫ్ గానేమో డిక్రీజ్ అవుతుంది, అదర్ ఎలిమెంట్ దట్ ఈస్ సల్ఫర్ యొక్క ఆక్సిడేషన్ స్టేట్ ని ఇంక్రీజ్ చేస్తుంది. కాబట్టి copper is an act as a oxidizing agent or oxidant. That means increase the oxidation number other elements and itself oxidation state decrease. అంటే కాపర్ తను ఓన్ గానేమో ఆక్సిడేషన్ స్టేట్ ను డిక్రీజ్ అవుతుంది, అదర్ ఎలిమెంట్ యొక్క ఆక్సిడేషన్ స్టేట్ ని ఇంక్రీజ్ చేస్తుంది. సో అలాంటి ఎలిమెంట్స్ ని ఏమంటారు? ఆక్సిడైజింగ్ ఏజెంట్ ఆర్ ఆక్సిడెంట్. సో ఇన్ ద రియాక్షన్, ఇన్ ఏ రిడక్స్ రియాక్షన్స్, one element undergo oxidation, the remaining elements undergo reduction. That's why sulfur can act as a reducing agent or reductant. It is oxidizing agent. So once again repeated, oxidizing agent, you will easily identify oxidizing agent itself oxidation state will be decreases and increase other element oxidation state. So I will explain easily. For example, here you take one compound, one element, so it acts as a reducing agent. That means you will see more, that means donor, it is a donor, it is another one empty element is taken, that is act as a oxidizing agent. Okay, so reducing agent is nothing but the substances which is undergo oxidation, that means loss of electron is called, that element can act as a reducing agent. That means reducing agent can act as a donor electrons, or donating electron capacity is a high. Now oxidizing agent accepting capacity is a electron acceptor, and oxidizing agent always undergo reduction. That means gain of electron is called reduction. Gain of electron is called reduction. So this is you will remember that. This is a shortcut method. So reducing agent, it will increase the oxidation state of the other element. Oxidation state will be increased. అంటే అదర్ ఎలిమెంట్ యొక్క ఆక్సిడేషన్ స్టేట్ ని ఇంక్రీజ్ చేస్తుంది. and itself oxidation state will be decreases. Itself oxidation state will be decreases. If you take example for the in copper plus 1 ions or copper plus ions, what happened? Itself oxidation state will be decreases. ప్లస్ 1 నుంచి 0కి వస్తుంది కదా, అంటే ఆక్సిడేషన్ స్టేట్ డిక్రీజ్ అవుతుంది కదా. సో కాపర్ ఇట్ సెల్ఫ్ ఆక్సిడేషన్ స్టేట్ డిక్రీజ్ అండ్ ఇంక్రీజ్ అదర్ ఎలిమెంట్ యొక్క ఆక్సిడేషన్ స్టేట్ని ఇంక్రీజ్ చేస్తుంది. సో -2 + 4 the sulfur oxidation state will be increased by the copper plus 1 ions. That's why copper plus 1 ions can act as a oxidizing agent or oxidant, and the sulfur can act as a reducing agent or reductant. So this is the information about redox reactions in terms of oxidation number.